Hi guys, I'm Holly, and today I will be helping you solve problem 2 from chapter 4, session 2A. I have it written on the board for you if you need any reminder what problem we are doing. I also have the problem written out, so if you're like, what are we trying to solve? It is up on the board, and I'll read it to you right now. It is, use a factor tree to find the prime factorization of the following, and the following are 504, and then 2,475, 11,250. So we'll start with 504. Write that on the board here. 504. So for a factor tree, we take all the factors and we split them down and go easier and easier. We are looking for prime numbers, so I'm going to focus on what prime numbers go into each of these bigger numbers. So I know that 504 is a even number, and one of our prime numbers that is even is 2. So I'll take 504 and then divide that by 2 to get what the other factor is. So I already did that, which is 252. Now, I want to find that 252 is not a prime number, so I have to break it down even more. I know it's an even number, just like 504, so I can use 2 to factor out. And then you'll do the same for 504 as you did. 504 divided by 2 to get 252. So you take 252, divide that by 2, which will be 126. And then see how it's still even? And it's not a prime number, so we can keep going down to 2's. So if I take 2 divided by 226, that'll give me 63. Now, 63 isn't even, but it also isn't a prime number. I know that because I know 2 factors that are on the larger scale that fit into this, and that is 7 and 9. So I'll put the 7 and 9 here, so I don't have to do any division. But 9 is not a prime number because I know that 9 is a square root of 2 numbers. And those 2 numbers are prime. And those 2 numbers are 3. So this is a factor tree of 504, but we can simplify it into a prime factorization by adding all the numbers together, for each of the quotients. So we have 1, 2, 3 2's, so I'll do 2 to the third plus, we only have 1 7, so it'll be 1 7, and then 3 squared, then 3 squared. So that is how we do 504. Now, for the next number, I'm going to erase this, is 2,475. So, I see that this number ends in 5. I know that one of our prime numbers is 5 and is easily divisible by 5. So, I'm dividing 2,475 by 5 to get another factor of 495. This still ends in a 5, so I know I can divide it by 5 again, which equals to 99. Now 99 isn't a prime, because just like 504, 3 can go into it. So I'll put 3 here, but what else 3 divided by 99 is 33. Okay. And then 33 is not divisible because 3 can go into it. But 3 divided by 33 is 11. 11 is a prime factorization, so I can't go any further. But we can simplify this into, we have 2 5, so 5 squared, plus 2 3's, so 3 squared. Oops, I wrote 3. And then 11. So that is how we do 2,475. Next one will be 11,250. So this one, you can go two different ways. Since it's an even number and it ends in a 0, you can divide by 5 or you can divide by 2. So because those are two solid prime numbers. I'm personally going to do 5 because it's a bigger number and it'll probably get me to the quotient, the finished product faster. So I'll divide by 5. You guys can divide by 2 if you want and tell me how that works out. So that'd be 250. And it still is even and ends with the 0, so I can divide by 5 again, which is 450. And I know I can put 7 in there and make it all like a finished, but I know it's still 0, so I don't know if I can fully grab it, so I'm going to do 5 again. And then that turns into 90. And I know 3 goes into 9, so 3 can go into 90 30 times. And 3 can go into 30 for sure by 3 and 10 and 5 and 2. Work out. So there's that.